There you go.
Oh my god.
All right, so let's start working on this. I'll go as far as I can for this period. Let's see. Log base 464. Again, you could always use your calculator to kind of cheat, but log base 464, you could rewrite that as 64 equals 4 to the x power. Then ask yourself, what to the x power gives you 64? That must be 3. So it's x equals 3. With that in mind, though, how do you use your calculator to your advantage? What you can do is use the change of base formula. So log 64, close the parentheses. Don't forget to close the parentheses. Log 4. And then that's going to become 3. So you can always confirm your answer like that. Log 12, 1. I showed you how to do it in the calculator, so you already know. But 1 equals 12 to the x power. So in this case, what to the x power? What 12 to what power gives you a 1? That has to be 0. So x equals 0 on that one. This one, we rewrite it as 1 over 81 equals 3 to the x power. I need to be able to move down, so we know part of the answer is going to be negative. And then I need 3 to become 81, so that must be to the 4th power. And again, you can use the calculator like I did in the first one in order to test all your work. Here, log base 25, 5. 5 equals x, or 25 to the x power. In this case, 25 needs to get smaller into 5. The square root of 25 is 5, so x equals a half power. Yeah, what's up, John?
Can you do like the log base thing?
Sure. What do you mean?
Like on the calculator.
Okay, so I'll do that for log 25, 5. What I would do is, because the top number's here and the bottom number's here, I would do log 5 divided by log 25. So in the calculator, because I have a log button, log 5 divided by log 25. 0.5, which is 1/2, that matches. Right. These questions, 5 and 6, is not relevant to your test because you have a calculator. So what you would really do here is just do log 45 in your calculator. 1.65. And then this one, 0.6. Negative 0.22. All right, expanding logs. Remember, when you see multiplication, that becomes addition. When you see division, that becomes subtraction. And when you see powers, it will become a multiple to the front, okay, or a multiplier. So in this case, I'm going to rewrite this as log 10 plus log x minus log y. Now, this is not how your answer would look like in a multiple choice, because log 10, if you don't see a log on the bottom, it's divisible 10, this could be simplified. So your multiple choice answer would look like 1 plus log x minus log y. So notice that I could actually simplify. So you have to look for that kind of answer in that case. Here, ln, anything that's an exponent moves to the front. So ln, 3 ln x plus 5 ln y minus, now, a 3 to the 4th root, you could rewrite that as a 3 to the 4th power. So I'm going to write 3/4 in front, ln a.
That's the whole answer.
That's the whole answer for this one. Can't be simplified anymore. So the reverse of expanding is condense it. So we're just going to put them together. Again, anything in front becomes an exponent. So log x to the 3rd, y to the 6th, divided by a to the 2nd. For number 10, that's what I'll do here. Half ln 9 minus ln 10. Ln, the square root of 9, because the half power is the same as the square root, over 10, which means I would simplify it to ln 3 over 10. Remember, the 10 is within the ln. I'm going to put a fake answer where it's going to look like this. Or, sorry, with a 10 on the bottom. Remember, the 10 should be inside the ln. This would be a wrong answer. That is the right answer. All right. Next one, we're going to solve for x. In this case, we're just getting x by itself. And then if you really wanted to, you could follow up with a calculator. So here we're going to take the e, move it to the other side. When you move the base of an exponent, it becomes the base of a log. So 23x equals ln, because ln's the special log for e, or natural log, ln 40. Divided by 23, divided by 23. X equals ln 40 divided by 23. I think I just leave it like this. If you need it as, yeah, this is x. Okay. Now, E, both of here are the same base. Because they're exactly the same base, I could just cross them out. Because I cross them out, it just becomes 3x equals x minus 12, which is the algebra 1 problem. X equals negative 6. Next one. They don't match, so we're going to make it match. So what I'm going to do is rewrite this as 2 to the third power times x minus 1 equals 2 to the fifth power times 2x. Let's do the arrow. That's going to become 2 to the 3x minus 3 equals 2 to the 10x. Hey, the 2's now match, so I cross them out. Solve the algebra 1 problem up here. Negative 3 over 7 equals x. Yeah, what's up?
This doesn't have to do with this, but are the inverse functions like the arcsine and arctan that kind of stuff?
Sine negative 1 is the same as arcsine.
But that's what it is then.
Yeah. Log x equals 4. I need to get x by itself, so I'm going to move the log base to the other side. If you don't see a log base, that must mean that is a divisible 10. So this is going to be x equals 10 to the fourth power. So this is multiple choice. It'll be written as 10,000. Here, log base 2 has to go to the other side. So x squared equals 2 to the 6th power. 2 to the 6th power is 8 times 8, 64. But x squared is not x is not done. Square root both sides. X equals plus or minus 8. Not just positive 8, not nor negative 8, plus or minus 8. Here, 16, we're going to condense these first. We cannot get rid of the ln's or exponents for that matter until they're condensed. So we're going to condense these. So it's going to be ln x minus 4 equals ln 12. Once they're condensed, I could now cross out the ln's. So x squared minus 4x, I'm going to bring the 12 to the other side, minus 12 equals 0. A little bit of factoring. X minus 6, x plus 2. So 6 and negative 2. The issue, though, is you're not allowed to have a final negative product inside a ln, or a log in that fact. So negative 2, if I plugged it in here, would be ln negative 2. That is not an acceptable answer. But trust me, on the multiple choice, I will have 6 comma negative 2. So know that you have to get rid of that. So the only one that's actually good is 6, because if I plug in 6 here, it's 6. And if I plug in 6 here, it's 2. They're both positive. It's okay. So it's 6. Next one, again, we need to condense this. So it's going to be x minus 2, log base 2, equals 3. This case, they don't have logs on both sides. So we need to bring the log to the other side. And once we do that, the base of a log becomes the base of an exponent. So it's going to be x squared minus 2x equals 2 to the third power, which is 8, and I'm going to move it to the left side. So x squared minus 2x minus 8 equals 0. Things that multiply to negative 8, that add to negative 2, x minus 4, x plus 2. then it's going to be 4 and negative 2. But negative 2, if I plug it into this one, will cause a negative overall. So that's not okay. So the only good answer here is 4. The only applicable answer is 4. Negative 2 is what we call extraneous solution.
The only reason it would be that number is because it would have to be positive.
It has to be positive. It has to not be negative, so 0 counts too. 0 could be inside, but if it's negative, that's the problem. Right. I must have printed something wrong or something. Oh, this is right. Okay, never mind. Okay, describe the transformations compared to e to the x. The baseline is a e x minus h plus k. So A is the vertical stretch / shrink.
What shape is this?
This is an exponential graph. So it's a curve like that.
Oh.
H is horizontal shifts. And then K is vertical shifts. So here we have a negative 3 up here, which means the H value is actually positive 3, which means it's going right 3. And here you have a positive 4 outside, so K is positive 4. So that means it's going up 4. Give the domain and range. For the domain, anything could go into an exponent, so it's negative infinity to infinity.
I am not going to change my good.
And the range is going to be the lowest point it ever will get to is the vertical shift because it starts low and then it shoots up high as an exponential. So because of that, the lowest it will get to 4. Yes, but it'll never reach 4. Because the e could never become 0 technically. So it's going to be 4 comma infinity.
Wait, is there a bracket over it?
No, it is a soft parenthesis because it'll never reach 4. There's an asymptote there. Or we could say if you were going to negative infinity, the limit is 4. It approaches 4 but never gets there. All right, 20. Describe the transformations compared to this ln x. So the base form is a ln, or log it could be, x minus h plus k. A, k, and h does all the same things. So in this case, there's a vertical stretch by a factor of 3. It's going to go left 1, and it's going to go down 2.
Wait, what shape is this?
It would look like this. So it's like an invert of exponential. So exponentials, it starts flat and then shoots up. Logs, they start shooting up and then they flatten out. Give domain and range. So it would look something like this. So the domain, I can't plug in a negative here. So the lowest number I could possibly have here is negative 1, right? It could be 0, so negative 1 counts. So that'll be a hard bracket for negative 1. But then after that, I could put any positive number here.
Why can't you put a negative in it?
Because it can't be a negative in a log. And then here, that's the domain. And here, the range, it goes up to a certain point. Oh wait, no, never mind. It goes up to infinity. It starts at a certain point. And it starts right at 2. Because if you make the 0, it'll be 0. So or it'll be 1. Oh, wait. ln 0 is
1.
Is 1, right? Yeah, so 3 times 1. No, wait. Log 0 is the same thing as saying 0 equals 10 to the x power. So what would that be? It has to be 1. So 3 times 1 is 3. So 3 minus 2 happens to be 1.
What?
So the lowest number it could be, because this could become a 1, 3 times 1 minus 2 would be 1. So your y value, the lowest y value you could get is 1.
That makes actually 0 sense.
comma infinity.
You're the one that
Can you,
said
can you
one.
explain it better?
Sure. Like, imagine if we're actually graphing this. I want to plug in the smallest number possible. And I know the smallest possible I could get is -1, right? That I could plug in without having...
And then up 2 from that.
Well, I plug in -1 into here. That causes ln 0. ln 0 equals 1. So it's 3 times 1 minus 2. Well, 3 times 1 minus 2 is 1. So my y value at -1 is 1. All right, next test.
We know how to test.
Change the 150 degrees to radians. 150 degrees of radians, the formula is 150 over 1 times. Remember, what you're changing to will be on top. So it's going to be pi, and what you're leaving behind is on the bottom. 180, so that's going to be 15 over 18, or 6 over 5. Or 5 over 6, in fact. So 5 over 6 pi. Next one, change radians into degrees. So 7 pi over 4. Good, because I'm aiming for degrees. I'm going to put 180 on top over pi. Pi's cancel out. 4 and 180 could cancel out to 1 and 45. 45 times 7. 335? 325.
315.
315? Yeah, 315. 28 and then another 35, yeah. 315. All right. Cosine 4 pi over 3. Now, cosine 4 pi over 3, you need to remember your reference or your unit circle, which is going to be at 4 pi over 3. It's over here in the second quadrant. It's going to have a 60-degree reference angle, or 1/3 or pi over 3 reference angle, which means the y value is going to be the higher part, so that's root 3 over 2, and the x value is the lower part, which is 1/2. It is negative 1/2 because you're going to the left. Wait. Yeah, wait a second. 4 pi over 3. I'm sorry. 4 pi over 3 is not in the second quadrant, it's in the third quadrant.
Oh, I just missed that word that you said.
So that is going to be, it's going to be the same numbers at least. Yeah, that means though, this is going to be root 3 over 2, negative root 3 over 2, and the x value is negative 1/2. Now, since I'm looking for cosine, I look for the x value, so that's negative 1/2. But on your test, you have a calculator. So I can pull out the calculator. Make sure when you're putting something in radians that you're in mode of radians. Click mode to change that. Then, the question was cosine 4 pi over 3. So cosine 4, you want to use the pi button because if you put 3.14, it won't give you the exact answer. Divided by 3, close parenthesis. Hey, that matches one of my answers. And it's going to match one of your multiple choice options. So you always could double check with that. Or maybe you just do it that way. Who knows?
There's a multiple choice. Are you going to do like one of those trick ones where you're going to put the answer that we would get if our calculator was in degrees?
Why would you give him that
Yeah,
idea?
seriously.
I already made a test, but next year, that'll be for next year. That's not a bad idea.
Does the answer no?
No, I don't think so. All right, secant 5 pi over 4. Now, secant 5 pi over 4, let's say we use the calculator. Let's say you had no clue. At least you know secant is 1 over cosine, right? So 1 divided by cosine, and it was 5 pi over 4. So 5 second pi over 4. You got this thing, and you're like, oh, crap, what is that? Math, enter, enter. Let's change it to a fraction.
It doesn't work.
Yeah, it doesn't work. But, let's see. 5 pi over 4, cosine 5 pi over 4 would be negative, it would be root 2, right? If you did the whole unit circle thing. Okay?
Yeah.
Now,
How'd you get that?
the unit circle. So it's going to be 45 degrees. Well, cosine, right? This is cosine.
Over negative
Root 2 over 2. So then you reciprocate it, which is 2 over root 2, which then you have to rationalize. So it becomes, I'll do it over here, 2 root 2 over 2. This is all negative, by the way. The 2's cancel out, so it's just root 2. Okay, so negative root 2. Now, you're like, looking at your multiple choice, there's 4 options. There's probably a bunch of square roots. So instead, you could do this. Negative second square root of 2. Wait a second, that matches the decimals I had. That must mean that negative root 2 is my answer. And you have a multiple choice question. So you could just use that and circle that. So negative root 2. Find cosecant when tan is negative 3/4 and the point is in quadrant 2. So this one is a right triangle thing. So your right triangle is something like this, quadrant 2. So we're going to go to the left here. Theta is nestled in the middle. Tangent is negative root 3/4. Tangent is opposite over adjacent, TOA. So opposite, which is 4, and adjacent, which is going to be negative 3. And the reason I know it's negative 3 is because I said it was a second quadrant. Opposite over adjacent. TOA.
Yeah, so it's negative 3 in the quadrant.
Yes, it is. I don't know why I read the numbers wrong.
Yeah.
So it's going to be opposite, which is 3, and then adjacent, which is negative 4. Good.
Why is it at the bottom?
Then you would want to find the hypotenuse, which is 5. Go ahead.
Why is the bottom the one that's negative?
You're in the second quadrant. So I'm going to the left here.
Okay.
Okay? And it says it here. So then, we're going to do cosecant. So that's going to be 1 over sine. And if we know SOHCAHTOA, sine is opposite over hypotenuse. So cosecant must be hypotenuse over sine. So it's going to be 5 over 3. Yes? No. Yeah, but I graded with an hour. That's why I do it like that. There's partial credit on the open-ended questions.
What's the answer?
5 over 3. All right, let's find the 6 trig functions that end at 6 comma 7, 6 comma negative 7. So right 6, down 7.
I decided.
So I'm going to 6, negative 7.
It doesn't have that.
So here's a right angle. So we should find the hypotenuse to help us out. 6, 7, 36 plus 49. 65? No. Was it? It's not 75.
85. It's 85.
Yeah, 85. Wait,
What are you doing?
85. Square root of 85 because we would square
You're
root.
doing math.
All right, sine is opposite over hypotenuse. So since your theta's here, it's always at the x-axis. Sine is opposite over hypotenuse, so negative 7 over root 85. But since it's a multiple choice, I will have it properly formatted. Negative 7 root 85 over 85. That's for sine. For cosine, that's going to be adjacent 6 over root 85, which we rewrited 6 root 85 over 85. Tangent, opposite over adjacent, so negative 7 over 6. Cosecant, so it's going to be the reciprocal of this, which you could reciprocate this part, so you don't have to reciprocate it and then recancel it. So it's going to be root 85 over negative 7. Secant,
Wait, what happened to how'd you do that?
I just reciprocated the original fraction to make my life a little easier.
Oh, okay.
And then I'll do the same thing for the next one. Reciprocate cosine. So it's going to be root 85 over 6.
And then negative 6 over 6.
Good. And then flip the tangent, negative 6 over 7. Next period's 4 though, right? Okay. Find the 2 values of theta if sine theta is negative root 3 over 2. All right, so this one would require a unit circle, but you could also use a calculator. First, I'll do the unit circle style. So you ask yourself, what sine values would be root 3 over 2? I'm going to keep going, and just so I can keep recording. You guys get free to go.
Do you have 4 periods?
No, so I'm just going to say
You're recording?
yeah.
Yeah.
So things that are negative root 3 over 2, we should recognize that is the 60 degrees angles or the pi over 3 angles. it's going to be in radians, the answers. So be prepared to do it in pi over 3. So sine is 60 degrees, so the pi over 3s. I need it where it's negative. So that's going to be sine over here in quadrant 2. And, oh wait, no, quadrant 2 sine is positive, my bad. So it's going to be here in quadrant 3 and here in quadrant 4. Okay? So quadrant 3 and quadrant 4 is over here. So in quadrant 3, it should be 4 pi over 3. And it's going to be 5 pi over 3.
I have no idea how you did that.
Well, if you have multiple choice, you can see what answers it could possibly be.
Oh, it's one of the pilots. Yeah.
So what I could do is take the calculator and do, what is this, sine? Sine, and then plug in 4
You do sine
pi over 3. That would be this number. You're like, I don't know if that's the right number. So you're wrong. But if you check, it should be negative root 3 over 2.
From just no radians?
No. Remember, on the test, you have a multiple choice, right?
Yeah.
So you could look at the answers you have and just test them out by plugging into sine.
Mr. Bryan's classes will be meeting in the ICE
What's up?
today. Mr. Bryan's classes will be
What?
meeting in the ICE.
Where you got?
Oh, why did I get these answers? Is that what you're asking?
Yeah.
Okay. Because I know it's negative, it's root 3 over 2. So I know it should be the 60-degree angles / the pi over 3 angles, okay? All right. So I also know, since it's negative sine, it must be in quadrant 3 and quadrant 4. So it has to be on the bottom. At here, it's 4 pi over 3. And in here, it's 5 pi over 3.
Oh, okay.
So I knew that. And then you could check your answer by just plugging it back into the sine using your calculator.
Okay.
Okay? I'm going to keep working. If you guys want to leave, that's fine. 20-foot ladder sits on the barn. So 20-foot ladder over here. Angle of elevation is 45 degrees. Keep in mind, angle of elevation is from the ground up. Angle of depression would be from the top down. Find the ground. Find the height of the top of the ladder. So we want to figure out what's here. So in this case, we have a opposite, we have a hypotenuse, and we have 45 degrees. So you could technically do sine of 45 degrees equals opposite over hypotenuse, so x over 20. Then do inverse, and then do times 20 on both sides. But this is a special right triangle. Because it's a special right triangle, I should know that this is A, and this is A root 2. So if I know it's 20 equals A root 2, I could divide root 2 on both sides. So I'm going to do 20 divided by root 2. I'm going to simplify that, which is going to become 10 root 2 after I do all my simplification and rationalization. This is how your answer is going to look like in the multiple choice. So make sure you know this just so you can find the answer correctly. Scan likely, not today. All right, no problem. But you can always plug it in this calculator and then confirm it. So for example, I could do 20 times sine 45. Keep in mind, this is in radians right now, so I should turn it into degrees first. So that's some number. But if I do 10 times root 2, hey, that's a matching number, so it looks like we worked out. Describe the changes from here to here. So for this one, it is A, the trig function, I'll write it like this. B, x minus h plus k. A is vertical stretch and shrink. We already did that. The only thing that's changed is B. It'll change the period. The period will be 2 pi over B, and that's for the sines and cosines. And the period for tangents is going to be pi over B, and that's for the tangents, okay? So We have a 3 in the front, so that is going to change the amplitude or vertical stretch. To a factor of 3. The h is a -1/2, so it's going to be a vertical shift to the left. So left pi over 2. And then it's going to go up 4. Or the midline will be up 4. Describe the changes from here to here. In this case, we have 2. So this means it's going to have a horizontal squeeze or a period of 2 pi divided by 2, which means that's just going to be pi. So your period is pi in that case, and it moves down 1. Fill the properties for this graph. Sine 2x sine -1. So the amplitude, because this is 2, is 2. The period, no change. So it's going to be a standard 2 pi. Vertical shift, you're going to go down 1. Or -1 you could put. Horizontal shift, you're not moving anywhere, so 0 or no. The range, so it's going to go as high from -1 plus 2. So it's going to be 3. And as lowest is going to be -1. Or oh wait. Let me rephrase that. So I know my middle line is going to be at -1. So here's -1. Here's where the middle of the curve is going to be. I'm going to go down 2 from there, which means I'm going to reach down to -3. And I'm going to go up 2 from there, so I'm going to reach up to 1. So that means my lowest is -3, and my highest is 1. Domain, there's no restrictions in plugging in anything, so negative infinity to infinity. Okay, so we're going to start. From here, we want our x values. So I know a period is 2 pi, and I'll double it to 4 pi. I could cut it in half, so that makes it pi. And I could cut it in half again to be pi over 2. This is going to be 3 pi over 2. Cut this in half, which is 3 pi. Cut this in half, which is 5 pi over 2. And then cut this in half, which is 7 pi over 2. Let me grab these so I can move them up. Okay. You got to make sure you mark your horizontal axes. All right, from there, sine wave starts at 0. So I'll start here. By the time I get to here, I'm on the top, middle, bottom, middle. And you should have one complete wave by you get your first period. Top, middle, bottom, middle, second wave right there. Now, to use a calculator to help you out with that, we're going to go to y equals. And it was, let me just look again, 2 sine x. So 2 sine x minus 1. I would say put the mode in radians just to be careful. And you're going to graph this. Now you're like, I don't know what the tick marks are because sometimes they're like not matching to 1 and 1. So what I could do is click second, or not second. I'm just going to click zoom. And then zoom trig is option 7 here. Now when it zooms in, it's a little bit more clear. If I click trace and move right a little bit, it kind of looks like my top 1.5, by the way, which is about pi over 2, is 1. And if I keep going, 3.14, which is pi, looks like a -1. If I keep going, looks like it's -3. So you could use that to help you see this. Second table, I don't think will help you. No, second table won't help you, but it will help you in that way. So you can use the graph to help you confirm. All right, fill the properties for these two periods. Tan 2xb, or 2x plus 1. The amplitude. So amplitude does not apply to here, but it's technically an infinite amplitude, or amplitude of 1, actually, I guess is more accurate. Nothing's multiplying to it. But remember, tangent goes all the way up and down, so it wouldn't make sense. Hey, what's up?
By any chance.
Yeah.
Are you recording?
Yeah.
Oh, hi. Oh my god, is this for our class? Because I'm going to listen to this later.
Yeah. Haley? Another one.
Is that an 8 or a 5?
8.
Alright, I have 5. I don't know if I can high five you, but see, this is why you see random people in the library and then you get them to help you.
You telling me the random person tell you that?
Yeah.
That's good. All right. So the period here is, since it's 2x, that means it's going to be pi divided by my b value, which is 2. So the period is pi over 2. No problem. Vertical shift, you're going to go up 1. Up 1. Positive 1. Horizontal shift, there's no horizontal shift, or 0. The range for trig, or for tangent, it goes up and down to infinity. So negative infinity to infinity. For domain, x cannot equal a certain part in the asymptotes. So let's graph it and then we'll talk about the domain. So tangent, 2x over 2. So my period is pi over 2. And then that will be a pi, that's 2 periods. And then we only need a half point here. So we go pi over 4. And this would be 3 pi over 4. All right. At your period starts, what we're going to do is we're going to make an asymptote here, and not there, and here. So your actual graph will be starting from here. I go up along the line, then whip back through, up down the line, whip back through. I guess I should have a point here. The coordinate point should be, oh, I made a mistake. I first shifted up 1. So let's call this 1 and let's call this line 0. What's up, Dylan?
Can I ask a question?
Sure, but it will be recorded.
You're not recording.
Let me see, wait. Yeah, come in like 15 minutes.
Okay, thank you.
All right. So it goes like that. And I had to put this at 1 for a vertical shift. My fault on that. And then this would be a 5 pi over 4, technically. If you want more detail, look at the video I made back in the past about tangent, okay? Here, evaluate arc cosine 1/2. So you're asking yourself, cosine negative 1 of a half, or another way to think of it, cosine at what theta gives you a half? Well, cosine is a half at 60 degrees, so that's going to be pi over 3. If you're not sure, though, you could open up the calculator here and do second cosine, so cosine negative 1. That was what, pi over 3? 1/2. That's 1.04. And then you remember, it's multiple choice, so you could just do pi divided by 3. Hey, 1.04. That looks like they're the same number. That must be the same answer. And technically, what you could do is also put the answer in degrees. And then do this. And you get 60 degrees and then convert it in your head. So I don't care how you do it, but you can use your calculator in many ways. All right, next one. Tan, arctan 3. Well, tan and arctan cancels out. So your answer is 3. If you want to ever double check, it was tan, arctan, right? Yeah. So tan negative 1, 3. Hey, it turns out to be 3. No surprise there. All right, this one though, sine pi over 4. Sine pi over 4, by the way, is going to be negative root 2 over 2. But the arc sines and the arc cosines and the arc whatever have a certain range. Arc sine and tangent is in the first and fourth quadrant, while the cosine, the arc cosine, is in the first and second quadrant. So when I say arc sine of negative root 2 over 2, I'm saying in the first or fourth quadrant, what causes sine to be negative root 2 over 2? Since it's going to be the fourth quadrant, which is negative, your answer is going to be here. It's going to be negative 45 degrees, but it's going to be in radians, so negative pi over 4. Okay. And again, you can plug it in a calculator to check it out. Arctan 3 over 4. In this one, I remember when we had the test, people were confused because they're like, how are we going to get the angle if I don't have a calculator? Here, you don't need the angle because if I know tangent is 3 over 5, which means hypotenuse is 5 and, I'm sorry. SOHCAHTOA, so opposite over adjacent, so 3, 5, which means 9 plus 15, this is going to be the square root of, or 25. 25 plus 9, 34. So arctan is opposite over adjacent, so 3 over 5, that's right. So then here, cosine is going to have to be adjacent over hypotenuse, which is 5 over root 34. But because it's multiple choice, it'll be written in the proper form, 5, 34 over 34. Okay, simplify the following expression into a single term. Let's see how much time I got. I'm going to stop here because I want to take care of other things. So I'll be back working on this later.